Hi, here's a method of teaching fraction division that allows the students in the class to actually derive the rule of multiply by the reciprocal or keep, flip, change, whatever you want to call it. So it's all about what are we counting, how are we counting it, and what is this similar to. So what are we counting? We're counting how many times something can be removed from another object, or how many times something fits into another object. How are we counting? We're looking at physical pieces. And what is this similar to? Well, the fractions, which we're not telling them the fractions, is very, very similar to something they already know. It's analogous to the number structures. So 9 divided by 3, they can see, they already know the answer is 3 because we can remove the 3 times from the 9. So that's why this 9 divided by 3 equals 3. Okay? Likewise, you can see 9 divided by 3 equals 3. There's no remainders. 9 divided by 4, now we're getting a little bit more abstract. We have a 4. It can be taken out once. It can be taken out twice. And then when we go to take it out the third time, we realize, oh, wait a minute, the whole thing doesn't fit in. About 1/4, 1/4 of the 4 can be taken out. So that's why 9 divided by 4 is equal to 2 1/4, or it's 9 over 4, which is the same as saying the 4 goes into the 9 twice, and then there's 1 over 4 remaining. Now, we don't say anything with the numbers. We've established this in their heads. 9 divided by 3 is 3, because it can go up 3 times. 9 divided by 4, it comes out twice, and then we still have a little bit remaining. What's the answer to this? And let them struggle with it for a little bit, but eventually some student will recognize that, oh, well, if this is the same question as this, the blue rhombus can be taken out of this 3 times. Okay? Don't worry about any symbolic notation yet. Just say correct, and then you can show them. If you have worthy pattern blocks, you can see that, okay, well, look, there's 1, 2, 3 of these in there, so it can be removed 3 times. This one, you'll see that, okay, well, that whole thing fits in there once, and then there's still another rhombus sitting over here. And that rhombus is half of this. So the answer to this question would be it fits in once and a half times more. It can be removed from the yellow hexagon. This one, the shapes are the same, the outlines are the same, they cover the same area, so it fits in once. Now, this one, the whole thing can't be taken out of here. Only part of it can be, because it's larger than the yellow hexagon. So the idea here is that we go 1, 2, 3, 4 parts, and only 1, 2, 3 of them will fit into here. So the answer here is 3/4, right? So once you've established the physical answers from the visual examples on the board, make sure the kids understand how we got these answers from the physical responses, from the physical pattern blocks. And then you go in, okay, we know these are the answers, the math has to match. So now you go in and you put in the symbolic notation. 1 divided by 1/3, if we're calling the yellow hexagon a whole. Don't tell them how we get from here to here, just let them see it. Over here, rewrite this as 3/2, and then now over here, 1 divided by 2/3. This one, 1 divided by 3/3. This one, 1 divided by 1, 2, 3, 4/3. And you get them to look at the number and say, okay, look, there has to be a predictable relationship that has to run through all 4 of these examples, and it has to be consistent. We can't change the rule part way. We're trying to come up with a rule for how do we get from this symbol, these symbols, to the answer. These symbols to the answer, these symbols to the answer, these symbols to the answer. And if they look long enough, they will realize that this is that flipped over. This is that flipped over. This is that flipped over, which doesn't make any change. This is that flipped over. So you've now derived the invert and multiply rule. So you say to them, okay, well, so what you're saying is that, okay, that has inverted, but we're not dividing anymore. This would be the same as 1 times 3 over 1. This one would be the same as 1 times 3 over 2. This one would be the same as 1 times 3 over 3. Is it consistently working? Yep, so far. This one becomes 1 times 3 over 4. Okay. The other important, really important thing that this establishes is for the kids is the following. What you want them to notice is that we're keeping the dividend the same. The dividend is this yellow hexagon every time. The divisor, what's the consistent trend that we're carrying through here? We're making the divisor larger. So here we have one small piece. We have 2 of them, 3 of them, 4 of them. What you want them to notice is, as this number here, this component is smaller than this one in magnitude, it will fit in more than once. The answer has to be more than one because it goes in more than once. As soon as the divisor is larger than dividend, only part of it will fit in. Your answer has to be less than 1. When they're equal in size, it equals 1. These are the kinds of things you want the kids to notice. The other thing that's really important here is we're keeping the fraction piece consistent, and what's changing is the numerator. So the 3 in the bottom of the fractions is staying the same. So what's happening is the numerator is getting larger. So here it's a 1, here it's a 2, here it's a 3, here it's a 4. What you want them to understand, of course, is that as the numerator is getting larger, the actual piece is getting larger, the less times it fits in. It's an inverse relationship. Okay? We go through this and we illustrate to them that as the numerator is getting larger, the answer is getting smaller and smaller and smaller, because as this piece gets bigger, the fewer times it will fit into the dividend. Okay? That's the first part that we want to establish. The second part of the fraction division rule to establish is what happens as the piece size gets smaller. So we look at these fraction block illustrations here, and they realize, okay, well, the red piece fits into this twice. The blue rhombus will fit in here 3 times. The green triangle fits in here 6 times. And then now you come to the symbolic notation again. This is 1 divided by 1 over 2. This is 1 divided by 1 over 3. 1 divided by 1 over 6. And the main thing that we want to establish here is that as the denominator is getting larger, what happens to the answer over here is getting larger. And the reason why you want to establish in their head is that you don't want to establish with them is that, remember, as the denominator is getting larger, that number on the bottom of the fraction is making the piece size get smaller and smaller and smaller. If that piece size is getting smaller and smaller, it fits into the whole more and more times. So that rule is an inverse relationship again. This number is getting bigger, the piece size is getting smaller. Okay, that's why the invert multiply rule works again. So when we're dividing fractions, we have a over b divided by c over d. The keep, change, flip rule means we keep the first one, we change this to multiply, we flip the second one. And the reason why we're flipping, again, is because it's an inverse relationship. We know that as this number gets bigger, this piece is getting bigger, it fits into this fewer times. Okay, so that's the inverse relationship. We know that as this number is getting bigger, the fraction piece is getting smaller, so it fits into the whole more times. So that's why this number ends up on top multiplying. As it gets smaller, it's fitting in more times. And as this piece is getting bigger, it fits in fewer times, it goes into the bottom. That's why keep, change, flip, or multiply by the reciprocal, that's why that rule works. Okay? Okay, so let's take a look at a bit of an uglier example. We've got 1.5, 5/6. We want the kids to recognize instantly that, okay, my divisor is smaller than the dividend, so my answer has to be more than 1. If we look at the picture, or look at the pieces, I should say, it's almost twice the size. So it's going to be close to 2, not quite 2, but we should be coming up with more than 1, something less than 2 probably. So let's take a look at the math. So this is 3 over 2 divided by 1, 2, 3, 4, 5 over 6. We've talked about the rule of keep, change, flip, or multiply by the reciprocal. So the 3 over 2 stays as 3 over 2. We change that to multiplication. This flips over. And again, the idea was that it's an inverse relationship. The bigger this number is, less times it fits in. The bigger this number is in the denominator, the more times it fits in. So that's why the inverse. And then we can do it 2 ways. I prefer to have the kids recognize that since it's multiplication, it's really all one piece. It's 3 times 6 over 2 times 5. If you have the kids understand that, then they don't really have to actually write that, but they realize that, okay, well, 2 and 6 can both reduce because it's all multiplications. 2 divided by 2 is 1. 2 divided into 6 is 3. 3 times 3 over 5, which is the same as it goes in there once, and 4/5, which is what we said. More than 1, because it fits in there more than once. And it's 4/5 is actually close to whole. And if we look at it, we can see that, yeah, this whole thing would fit in here as such. These won't stick, no, I don't think. Oh, they do. Okay. 3, 4, 5. And then to cover off last week, we need another 1, 2, 3, 4 of those triangles, which is the 4/5. All right.